Bismillah, Bismillahirrahmanirrahim. Exercise 1.3, question number 3, part 8. Limit when x tends to 0, 1 minus cos x divided by sine square x. So our first observation that it is in the form, it is in 0 by 0 form. So what do? We are going to multiply and divide by 1 plus cos x. So we get it like this. Now this 1 minus cos x into 1 plus cos x becomes 1 minus cos square x, and then it can be written as sine square x, and sine square x got cancelled and we are left with this. Now we apply the limit, and when we apply the limit, we get limit when x tends to 0 of cos x equals to 1. So the result is 1 by 1 plus 1 equals to 1 by 2, which is the answer. Part 9. Limit when theta tends to 0 sine square theta by theta. Our observation, it is in the 0 by 0 form. So what do? Which of course 0 by 0 form is not defined. So to adjust it, we multiply and divide by theta. Let's see theta here, and now what we will do? We will multiply these two thetas and we will get sine square theta by theta square, and we keep this theta separate. Now this can be written as sine theta by theta whole square, and now we are going to apply the limit. We will write the limit here and we will write the limit here. And what is our observation? This limit is equal to 1 and this limit is equal to 0. So we get 1 square into 0 equals to 1 into 0 equals to 0, which is the answer. Part 10. Limit when x tends to 0 secant x minus cos x divided by x. First observation, it is in 0 by 0 form. That is, if we apply x equals to 0 directly, we are going to get 0 by 0, which is not defined. So we try to adjust it. For that, we are going to write this secant x as 1 by cos, and then we can take the LCM. And when I take the LCM, I get 1 minus cos square x by cos x, and then I write this cos x over here. Okay. So now this 1 minus cos square x can be written as sine square x. And now what do we have? We have sine square x here. So we need an x square down there. So we multiply and divide by x. Here it is. So I write it as sine square x divided by x square into x by cos x. You can say it like this, and this can be written as sin x by x whole square. And now we will apply the limit. We will apply limit here, we will apply limit here, and we will apply limit here. You can see it. Limit when x tends to 0 sin x by x whole square, this limit will become 1. Limit when x tends to 0 of x, this will be 0. Limit when x tends to 0 of cos x, this will be 1. So I will get 1 into 0 by 1, which is equals to 0. That is the answer. Part 11. Limit when theta tends to 0, 1 minus cos p theta divided by 1 minus cos q theta. And our observation that it is in the form 0 by 0. That is, if we apply the limit directly to this and to this, we will get 1 minus 1 by 1 minus 1, that is 0 by 0, which is not defined. So what do? We apply this result. 1 minus cos p theta is equal to 2 sine square p theta by 2. We apply the half angle identity. 1 minus cos p theta equals to 2 sine square p theta by 2, and 1 minus cos q theta equals to 2 sine square q theta by 2. Make both these adjustments over here. Now this 2 and 2 got cancelled and we are left with sine square p theta by 2 and sine square q theta by 2. Now we are going to multiply and divide by p theta by 2 whole square and q theta by 2 whole square. You can see it there. Multiply and divide by p theta by 2 whole square. Multiply and divide by q theta by 2 whole square. And now what we will do? We will write this p theta by 2 whole square under this sine square p theta by 2, and this sine square q theta by 2 above this q theta by 2 whole square, and the remaining p theta by 2 square and q theta by 2 square, they will be written separately here. You can see it like this. And now what I am going to do? I will write it as sine p theta by 2 by p theta by 2 whole square. You can see it there. I will write it as 1 by sine q theta by 2 over q theta by 2 whole square. You can see it there. Into p square theta square by 2, q square theta square by 2, theta square 2, 2 square, theta square 2 square both got cancelled and I am left with p square by q square. And now we can apply the limit, and we will apply the limit here and here and here. And what do we observe? We observe that as theta tends to 0, p theta by 2 tends to 0, q theta by 2 tends to 0. So the result we will get is this limit will become 1, this limit will become 1, and this will not be affected because it does not have any theta in it. And this is the result. 1 square divided by 1 by 1 square into p square by q square, and p square by q square is our answer. Next part, limit when theta tends to 0, tan theta minus sin theta by sin cube theta. What do we observe? That if we apply the limit directly, we get 0 by 0 form, which is not defined, so it is not acceptable. So what do? We change this tan into sin by cos. You see, I can take the LCM. So I took the LCM, sin theta minus sin theta into cos theta divided by cos theta, but then I write this cos theta here. You can see it there. You see, we can take sine common. So we took sine common, and now this sine can be cancelled by this sine cube, and we will have a sine square here. Now write sine square theta equals to 1 minus cos square theta, and then it is 1 minus cos square theta equals to 1 minus cos theta into 1 plus cos theta. Now these two got cancelled, and now we can apply the limit because 0 by 0 form is no more there. So we will apply the limit here, and we will apply the limit here. In both cases, limit when theta tends to 0, cos theta becomes 1. So I will get a 1 here, and I will get a 1 here. So I will get 1 by 1 into 1 plus 1, that is 1 by 2, and that is the answer.